So hello everyone, mic test, 1, 2, 3. I hope I'm audible right now. Let me just check the screen. So I'm just setting up the Twitch stream as well as my YouTube stream settings right now. Let me just take around 5 minutes to set this up in the background, and let me check the audio quality, video quality. Just checking the audio quality. Okay, cool. Hello. 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 What's your name, Kinku? Hey, it's going good, man. I'm just starting a new stream. Today's plan is to grind LeetCode, blind 75 list. I just got started. How's it going? For me, it's going good. Just trying to solve problems. It's been a long time since I've been seriously solving problems on LeetCode. So I thought, hey, let's do this with an audience. Alright, so hopefully you can see my screen. So I've just opened up LeetCode.io. It's a free plus on paid platform. Let me just start from scratch. I'll just delete the progress. I just like this platform because he has organized the list of problems very neatly, and so as you can see, there's a link to the LeetCode problems, difficulty rating, as well as the solution. So in case I don't know the answer, I can just review it once, go through the video explanation as well. So I've just opened this up. Here's the LeetCode platform. Let me just go through my old profile progress. Yeah, LeetCode. So LeetCode is this. It's like a course platform. So basically, there's a person called Navi. He's a YouTuber who has built this platform. He's currently he has been teaching for over 4 years on YouTube for free, and right now he has launched some courses on his own website called LeetCode.io. I can just show it to you just a second. You don't need to take any courses. I'm just using his free resources right now. I just like this list. It's very clean. So this is what he does. So basically, he has courses and stuff, but what you see here is all free. So there's a lot of free content that he has. Let me just pull up his YouTube channel. Yeah, so just subscribe to his channel, that's it. He has like literally, I don't know, 400 videos. There's another channel that he has, LeetCode.io. So this is the guy. He has worked in Google, helped lots of programmers learn how to code on LeetCode. So that's who he is. So okay. So that was just the background. See over here, there's 600 videos, 400 videos, total of 1000 videos. Okay, let's get back here. Yeah. So let me just explain what is blind 75 problem solving list. So there's this website called Blind, so where people anonymously post their interview experiences, the problems that were asked to them in big tech companies, right? Fan companies like Facebook, Amazon, Netflix, Google, Microsoft, a lot of startups, a lot of big tech, high paying jobs, right? So what they do is they all test us with this subject called data structures and algorithms. So how do you get good at it? You first learn the theory and then you practice, right? So theory is mostly covered in all computer science degrees. Practice, we don't do that a lot in college. What we do is we just sort of do only theoretical stuff. So that's where LeetCode will help us, right? So let me just set this all up. Just a second, I'll just answer the question on the chat as well and then get back to the stream. So basically I have solved over 240 problems so far, and it's been a while. 2024 there's not a lot of progress. 2023 around July, I think that was placement. After placement, I don't know, I think 2022 was when I was very serious about it. 2021, yeah, that's the most active time. Just solve every now and then, and there's, I think that's a list of solutions that I submitted and so on and so forth. Okay, so let me just get back to problem solving. So this is the blind 75 problem list. So today we are going to start with the first problem, contain duplicate. So let me just open up the problem on LeetCode. Okay, so today's problem is contains duplicate. So I basically solved this problem before, a while back. Let me just check the submissions. Yeah, on 2023, 2021. So let me just forget all that and start from scratch again. What we'll do is we'll read the problem, we'll understand how to approach the problem. I will be using Java to solve all the problems. So in this stream I'm going to basically follow the blind 75 list. So each category has a set of problems from array, two pointers, sliding window, stack, binary search, linked list, trees, heap, priority queue, backtracking, tries, graphs, advanced graphs, 1D dynamic programming, 2D dynamic programming, greedy, intervals, match, and geometry, and finally bit manipulation, right? So we'll just follow this order strictly and solve each problem one by one, and then mark our progress here. So I just logged in over here. This list is purely for me to have a clean progress tracking sheet, as well as have access to solutions. That's it. Okay, let me just close problems. I just close this, only open up these two tabs, right? Okay, contains duplicate. So in this problem they have given an integer array nums. So return true if any value appears at least twice in the array, and return false if every element is distinct. Okay, so they've given us an example. So in the first array we have 1 2 3 1, and we have to return true because element 1, the number 1, right? So it occurs twice, one in index 0 and index 3. So in programming, generally speaking, the index always starts with 0. So 0 1 2 3. So there are duplicates occurring twice. In example 2, there is no duplicate, every element is unique. Example 3, there are so many duplicates. All you have to do is return true, and they have given us constraints. So the constraints are very important. So if you study time complexity, the constraints tell us how to solve the problem in an optimal way that is accepted, right? And this is very important in an interview. Whenever an interviewer is going to ask us this question, they'll only give this statement. That's it. We have to ask ourselves, what are the edge cases, right? What are the examples? What are the edge cases? Edge cases are basically examples that will test the end result, right? So yeah, so examples, edge cases, and constraints. So while solving this problem, I'll get to the constraints part. Okay, let's get started. So the very first thing that comes to mind is the brute force approach, right? So what is the brute force approach? We have to find if the same number occurs again in the array. So in that case, what we have to do is we have to sort of loop through the array and check if one occurs in the remaining part of the array, right? So we are at index 0 and there is this number 1. We will check index 1, index 2, index 3 if 1 exists. If 1 doesn't exist, we will go to the next index and then take the value 2 and check if the remaining part of the array contains 2. So that will be index 2 is having 3, so no. Index 3 is having 1, so no. So we'll repeat this process, and in this way this brute force approach is going to be probably O of n square. So I'll just break it down when I code this out for this process. So that's what came on top of my head. Okay. So right, let me just so I'll write some notes over here, right? So the first thing is brute force solution. Here we go through every single element check duplicates. Okay. Let me see how we can trap this code. I think that's not going to happen. Okay. So how do I code this up? Okay. So just let me write a for loop. And I is equal to 0. I less than the length of the array, so nums.length in Java I++. So this is to go through every single element in the array. So this is iteration number 1, right? But the thing is, we need to go through the array again so that we can compare the current element with the next element, right? So I'll just declare a variable called current. So this process is the process of writing these variables is very convenient to explain the code. We can do it more optimally with lesser number of lines, but still writing this way is like thinking outside our mind, right? So the more we communicate, the better it is in the interviews. So that's very important. So that's why I'm writing int current is equal to nums, which is the array name, nums of I. Okay. So each time we look through this array, we'll store the current value inside this variable, right? Next we'll go through another for loop in j equal to 0, j less than nums.length, again j++. Now just add a thought. So we don't need to go through the array again from the start because we are already in the current, right? So we only need to go to 2, 3, 1. So when we are in 2, we only need to go through 3 and 1 because we already checked 2 and 1 in the second iteration. So let me just draw. Let's go to draw.io so that I can visualize this. Right. Okay. This is not what I was looking for. Let me see. Let me open up a whiteboard so that I can just draw some things. Use this tool called Xcalidraw. It's very easy to use. Okay. I just stretch my legs a little bit and just turn off this camera for a second. Alright, so there is this array, right? 1, 2, 3, and then 4. So yeah, so they have given this example, right? So let me just go through how I'll use the brute force approach to compare the duplicates in this array, right? Yeah. So yeah, in this array they're given 1, 2, 3, 4, right? So here in the first loop, our current element will be right? So in the second loop, so this is loop 1, I. For loop 2, we don't need to start from 1 because that's the same element, right? So we can start directly from the index 1. So let me just write the indexes here. So 0, 1, 2, 3. So this is the index, right? Sorry for my handwriting. This one. Okay. So the array and the index, right? So we don't need to do this particular one. We can directly start from 1, 2, 3. So that's why in this code what I'm going to do is, instead of starting from j equal to 0, I'm going to write j equal to I plus 1. Okay. So when j is equal to I plus 1, whenever we go through the first loop, we'll always start one place ahead, so that we don't repeatedly go through the same element and we don't go through the elements we have already covered before, right? So in iteration 1, what we will do, the current will stay here only, it will be fixed, right? This will be fixed, but j will go to 2 and check whether current is equal to 2, and then it will go to 3 and check current is equal to 3, and then go to 4 and check current is equal to 4, right? So this is how iteration 1 will look, right? So let me just write this particular logic there and then come back to this diagram. Okay, so I'll check for duplicates over here. Current, right? So the current is equal to so nums of j. So nums of j is basically we can say, let's use another variable so that we can sort of verbalize it more. Okay, so what do you call this? Let's call it x. Simply let's call int x is equal to nums of j. Okay, so this will check elements in the remaining array, remaining part of the array, right? So if current is equal to x, so what is the case? So let's say if in this example the current will equate to 1 when we hit the last index. So in that case they've simply told us to return true if the value appears twice, right? Otherwise return false. So let's just go ahead and then directly return true, because if we have found out even one duplicate early in the array, we will simply return true, because that's the answer, right? So we return true, and then outside of both of the for loops, if we never return true, that means every element is unique, right? So we'll simply return false. So we just show how this works, iteration by iteration, and then you will understand the logic. So in iteration 1, the current is 1, right? So 1 is not equal to 2, 1 is not equal to 3, 1 is not equal to 4. So this loop will end, and then we'll start the second iteration. Second iteration, what will happen, right? Second iteration, I will be over here. I will be over here, where current is equal to 2, right? So this is where the j right? So let me just go back to the escalator and go through the iterations, right? In the second iteration again, current is 2, so we don't need to check the first element because it's already checked, right? So we don't need to check this one. You can simply go to, you don't need to check the existing element as well for j. Let me just write this neatly for j. So j is this, right? You can simply check the current element 2 with 3 and 4, right? So 2 is not equal to 3, 2 is not equal to 4, and what we'll do, we'll go to the third iteration. The third iteration, i's current value will be current equal to 3. So as you can see, because we have used right, sorry for not sharing the screen first. So because we are using j equal to I plus 1, we're simply skipping this part that we have already covered. In this way it's kind of efficient but not completely efficient. So when current is equal to 3, we don't need to check the first 3 places, we only need to check the 4th place. So 3 is equal to 4, no it's not. So we'll go to the next iteration, which is the 4th iteration. In 4th iteration, I will be at current equal to 4, but here the j will not run because the j has already got checked the number 1, number 2, number 3 as well as number 4 as well, because here j is equal to I plus 1, which is equal to 5, right? So this, the second loop will not run, so the program will stop here and we will return false. Now this, the answer is false, right? But if the last element was 1, we would already checked it in the third iteration itself and returned true. So that's how this example will work, and how this example will work, right? So let me just run this code. As you can see, it is accepted for every test case. Let me just submit this code. So the time limit has exceeded. We put it here. So this is because, like I said, the constraints, right? So the constraints, so as you can see, 70 out of 76 test cases passed, but the constraint fails because there's a very big input, right? When the input is bigger and bigger, the solution has to be efficient. Otherwise, as you can see, the constraints, in the constraints, the size of the array can go to 10 to the power 5, and the value of the array, right, value of the element, sorry, that will go to 10 to the power 9. So handling those many number of inputs is not possible with a algorithm like this, because we are using 2 for loops, and for 2 for loops the time complexity will be O of n square. Okay, so this is the brute force approach for contains duplicate. Okay, so how do we solve this problem in the optimal way? So there are multiple approaches to solve this problem optimally. So let me check that. let me take a break for few minutes. I know because I was in between handling some work related stuff, so let me just pause the video here, or should I stop the stream and then continue later? What to do? So let me just stop the stream right here. So in the next stream I will continue with the better approach for this problem and an optimal approach. So kind of there are, I think, 2 or 3 more approaches to this problem, and I will be solving that with Java. So for now let me just stop the stream, and thank you for watching.